So not only are these various spheres of the planet interacting today, but as we've just seen, the interaction can take place on enormous timescales and over great distances. Less than 200 years ago, it seemed obvious to most everyone that the surface of the planet was one continuous layer, with bumps and dips, of course, but still like a skin stretching over the globe. It was a layer that sometimes dropped down miles to the floor beneath the oceans. That all changed with the discovery of plate tectonics, with the discovery that the surface is actually carved up into a variety of massive plates, some continental and others oceanic. Furthermore, these plates are on the move. And we now know the Earth is made up of three main shells: the very thin, brittle crust that we're all familiar with, the mantle below the crust, and the core at the very center. Although the core and mantle are about equal in thickness, the core actually forms only 15% of Earth's volume, whereas the mantle occupies 84%. The crust makes up the remaining 1%. A layer of rock 5 to 25 miles thick. It is primarily made up of igneous rock, such as these granites found in the Sierra Nevadas. For every rock type, there is a process that produced it. The origins of igneous rock lie below the hard and brittle crust. Here, temperatures are so great that minerals exist in a molten liquid state called magma. When cracks appear in the crust, magma is forced upwards by internal pressures. Intrusive igneous rocks are formed from magma that very slowly cools, solidifies, and commonly crystallizes within the crust. Over time, erosion can expose some of these solidified igneous blocks. Perhaps the most spectacular example of this process is Devil's Tower in eastern Wyoming. Of course, when magma is extruded onto the surface of the Earth, it cools more rapidly, producing the volcanoes and lava fields that are found throughout the world. The least common crustal rock type are sedimentary rocks. Rocks that have been formed by the buildup of sediments and minerals, layer upon layer, either in the ocean or on land, such as those found in the Badlands at John Day Fossil Beds. The second most common rock type making up the crust is metamorphic rock, which is the most frequently found rock type in the Appalachian Mountains. Sedimentary rocks become metamorphized when they are subjected to heat and pressure, usually related to mountain building. Metamorphized sandstone, siltstone, shale, and limestone are found throughout the Appalachian mountain range. And in places, their original sedimentary layering is clearly visible. It is out of these three rock types that virtually every land formation has been shaped and formed over time by a wide variety of forces on varying timescales. However, every landform visible on the planet today was created after the Great Extinction event that killed most dinosaurs 65 million years ago.